We are posed with this situation. In segment DF, E is between D and F. DE equals 4x plus 2, EF equals 6x plus 6, and DF equals 8x plus 10. Determine the value of x and the length of each segment. Since we don't have a picture, that is our first step, to establish a picture and get a visual of what we're looking at. Here's my segment, and I will label it with the points. Since I know that it's segment DF, I know the endpoints are D and F. And it says that E is in between D and F. Now I can really put E wherever I want. It's okay if my picture isn't necessarily drawn to scale. This is just so I can understand the different measurements in the segment. Now I'll label with each expression. DE measures 4x plus 2. EF measures 6x plus 6. And the whole segment, DF, measures 8x plus 10. Now I can follow the directions, determine the value of x. I have to do that before I can put the second half of the answer. I can use the segment addition postulate to create an algebra situation. I know that DE plus EF has to equal DF. So now I'll just replace those segments with their measurements. 4x plus 2, that's DE, plus 6x plus 6 equals DF measures 8x plus 10. From here on out, it's just a simple algebra problem. I'm going to combine the like terms, 4x and 6x, add up to give you 10x, and then 2 plus 6 is 8. And that's still equal to 8x plus 10. Now I'm going to move some terms around and get all my x terms on the same side. I'm going to subtract 8x from both sides. So I have 2x plus 8 equals 10. Now I'll subtract 8. And I have 2x equals 2. I'll divide both sides by 2 to isolate the x. So I know that x equals 1. So I answered the first part of the question. Now I need to complete the rest. Since DE equals 4x plus 2, then DE has to equal 4 times 1 plus 2, which is 6. Now, EF is 6x plus 6, or 6 times 1 plus 6, which equals 12. And I could find DF one of two ways. I could simply add the 6 and the 12 to get 18, or I can say 10 times 1 plus 10, which is also 18. And those are my solutions.